Hey everybody, welcome to the first installment of Coding Hell. Today we're going to be talking about our data structures, just to get you an idea of how R puts things together, and hopefully by the time we're done with this, a lot of kind of confusion about some of the error codes you'll get will be cleared up, and hopefully you'll just have a better understanding of how R stores some data. So let's move my head over here. Hello, and get started. So most of the stuff I'll be talking about, I found at this website. This is just the R's project for introduction into how it stores stuff. This is an R Markdown file that I'm going to be going through. You can find it here. I'll post this link in the Coding Hell channel. So for those of you who are not computers peoples, which is a majority of us, I think, R is what's sort of known as an object-oriented programming language, which means everything is kind of a member of a class, and it can have multiple features. So it's like the example I give here is, let's see here, I got to read this faster. So you have different features. So like a class would be like a dog, and dogs can have features like long hair or short hair or brown fur or green fur, or be nice dog or a mean dog, and weights and blah, blah, blah. So like all of you would be members of the class Gertz, and that gives you a higher propensity to steal things from the Farley lab or publish papers and stuff like that. So we're going to talk about data objects, and data objects are how R stores information. And the way it does that is the simplest ones are vectors. Getting more complicated, it's matrices, then factors, then lists, and then data frames. And functions count as a data storage object, but we're not going to talk about those in this lesson. So you can think of each one of these as like, an example I give is like a vehicle. So some vehicles are built to do one thing, and they're great at that one thing and not great at other things. So the example I give is vectors are like these, like a nice sedan. Like it's good for most people, but if you have a lot of data, maybe it's not the best thing. Or if you have lots of types of data, maybe you want like a semi-truck, which would be, I don't know, more like the data structures here. So first thing we're going to talk about is a vector. So if you go through in R, and if you just go through and kind of execute these codes that I'm going to show here, hopefully we'll pop up the console and you'll be able to see this. I don't know if I can clear my console, whatever. Okay, so like if you were to just do x equals 1 and then say print x, you'll see this little thing where it has a square bracket 1 and then the number that you assign to x. So that is a way of indicating that something is a vector. Hold on. And so pretty much anything you store just with assigning a single something to a variable will be stored as a vector. So if I say x equals c and then we say print x, look, again, we've got that little square bracket 1 and then c. So we could do something like x equals fish food. And then if we look at what x is again, it's a vector with fish food in it. So that pretty much any time you have a variable, it's just a vector with a length of 1. Now, if we want to make a vector that has a longer length, so let's just say the numbers 1 through 7, we can use the C function, which is concatenate. So let's try that here. We assign x equals c 1, 2, 3, 4, 5, 6, 7, comma separated, and if we print x, and look here, we've got a vector that now has all those numbers in it. And if you wanted to, you can access all of them together by printing x, or you can access individual pieces of it. So if I say x square bracket 1, that means we're grabbing the first item in the vector. And if I say x squared bracket 5, that means we're grabbing the fifth item in the vector. Now, just a point of clarification, if you do a lot of programming, a lot of things actually start with a 0 instead of a 1 when it comes to positions in a list. That's just like standard programming. R is not one of those. R's, the list starts with 1. So if you ask for x1, you'll get the first item. But if you were in, say, Python or Bash or C or any of those other languages, if you said x squared bracket 0, you'd get the first item. And x squared bracket 1 would actually give you the second item. But that's neither here nor there for this, just filling you in. So vectors can store lots of different data types. So we've been storing numbers. We could store a list of letters. So if we make a thing called alph, you can put a bunch of alphanumeric letters in there, or even combine them into larger ones and make strings. We can store doubles, which, full disclosure here, all numbers in R are technically doubles. You can force them to be integers, which means whole numbers, but by default they're stored as doubles or decimals. So if we say print alph, now we got a vector with ABC. If we say print double, now we've got a thing with decimals. And again, we can access different parts of them. So we can say alph3, and that'll, not alpha, alph3, and that'll give us the third item in that list. Or dub2, that'll give us the second item in that list. So you can combine different vectors together, again, using the concatenate function. So let's say we wanted to combine our x vector, which is this one, and our alph vector, which is this one. Then we can say new vector equals alph cat x alph. So we're concatenating those two vectors into a new one. And that gives us a new vector. But what you should notice is that now all the numbers have quotes around them. And this is a problem you may run into when you're doing stuff in R, which is you can't have two types of data in a single vector. So in this case, it converted all the numbers into characters because one can be both a character and a number, but A and B can't be numbers. So it just converted them into the type that they share. So yeah, that's one thing to pay attention to. Now what's interesting is we can perform math on large data sets using vectors. So let's say we've got our vector x here, which is the numbers 1 through 7. If we say x times 2, what it's going to do is it's going to take every single member of that vector and multiply it by 2. So you can see the outcome there. You can also use most functions this way. So let's say we've got alph here, which has A, B, C, D, E, and we say paste. We run the paste function, and let's see here. We say paste alph and the letter E. And what that'll do, keep typing alpha. What that'll do is that'll go through and it'll run the paste function on every member of the alph set and add E to it, as you can see by the output there. So there's a lot of interesting things you can do with that. You can also do math on two different sized vectors. So obviously, if I say x times 2, technically I'm doing vector x, which is 7 long, and I'm multiplying it by vector number 2, which is a single unit long vector. And as long as the vectors you're working with are multiples of each other, you can actually do math with them together, and it'll, let's see here how to explain this. It'll basically go in order and apply the function. So like, let's see here, I've got this vector named x, which is 1, 2, 3, 4. I've got a vector named y, which is 2, 3, 4, 5. Now if I do x plus y, it's going to take 1 and 1 and add them together, 2 and 2, 3 and 3, 4 and 4. So you can see 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 4 is 7, and 4 plus 5 is 9. And you can do the same thing. You can do math with it, whatever you want to do. Or we can do it, say we take y and we make it only 2 long. We can still do the same thing, but the difference is it'll do 5 plus 2, or 5 times 2, 6 times, sorry, it'll apply, oh, that's bizarre. Sorry, I forget what I'm doing sometimes when I'm recording these. All right, so I've got y and 6, and then we can do y times x. All right, there we go. So 5 times 1 is 5, 6 times 2 is 12, 5 times 3 is 15, 6 times 4 is 24. So it'll just alternate back and forth. And it's, again, as long as it's a multiple, one set is a multiple of the other, it'll do the math. And you can do multi-step operations and it'll still work. So here's my example is x times y plus 2. So it'll do the x times y, and then it'll do the next step and add 2 to each one of those numbers. So you can get real crazy with the math or the way you apply functions to these things to change how they look. Now the vectors I've been talking about so far are one-dimensional? Yes, are one-dimensional. So that means you only need to use one number to tell where you are in the vector. But you can actually combine these into tables using the rbind and cbind functions. So let's go up here, and I've got x and y defined as 2 different vectors, and we can combine them. So let's do rbind x comma y, and you can see it took those 2 vectors and put them into one table with their names on the left side and their positions on the top there. If we wanted to do cbind, it's going to do the same thing, but it's just going to bind them as each vector is a column as opposed to a row. So cbind x comma y. Now you see the x and y are in the column positions. So if you want to combine data sets together quick and simply, this is the way you can do it. So let's see here. So one thing to keep in mind when you're doing this is that R doesn't want to do this if your vectors aren't the same length. So let's do cbind x, y. You can see I've changed the y vector to have an extra digit in it. And it throws a warning message and says, hey, these vectors aren't the same length. So let's just see what this looks like. So essentially what it does is it's like, I don't actually know what to do with this. So it starts repeating the x vector to try and just fill it in, because it's guessing that you probably want it repeating. I don't know what it's thinking, but when people wrote R, they were crazy and came up with all kinds of weird things. But most of the time it'll just say, no, I won't do it. So that's fun. Anyways, so let's say, so now we've got this vector, this 2-dimensional vector called f. Now you can do things like access the first row, and you got to give it a comma now because there's 2 dimensions. So if you give it nothing for the second, it'll just give you the whole row. which is 1 and 5. If you give it nothing for the first position, which is the row, you just give it a column position, then it'll just give you that column as a vector. Or you can grab individual cells from the table. So there you go. Or you can grab ranges of cells. So the column basically says give me positions 3, 4, and 5 for the rows 3, 4, and 5, and the first column for those rows. And that's what you get. You can also, so if you see here, there's also, we gave them column names. So you can access things using their column names. Let's see here. So if we say f x, it'll give us the column of x. Surprised that actually worked. That really shouldn't have worked. Oh, so if we put, sorry, that didn't work. So here's the tricky thing about R is it just grabbed the first member of the x variable, which I have defined as this, and grabbed all those positions. So let's see here. Let's try this. We'll do remove x. So now x is set to nothing. Now if I say fx, it should give me an error. It's like, I don't know what the heck you're talking about. Now if we say give me column x in quotes, it'll give me the column x. So you can actually access these names, these columns based on their names. Instead of their positions, say you know the name of the data you want, but you don't know its actual position in the table, you can just give it the name. And if you want to assign, say this one doesn't have row names, you can assign row names with another vector. So let's see here. So ALF has 5 letters, so let's do row names. So you do row names, the vector that we're giving the row names to equals ALF. And now if we look at F, now we've got A, B, C, D, E as the row names. So we can say, give me values for row F, column Y. Because there is no F. Let's say row E, column Y. And there we go. We've got 9, which is where E and Y intersect. So that's just a way you can access it. We're going to talk about data frames and lists in a little bit, but a lot of people will see the column names and the row names, and they'll want to use the $ operator. So they'll say F $Y, and you'll get this mysterious message that says $ operator is invalid for atomic vectors. So atomic vectors are the simplest of vectors, and you cannot use the $ operator. So if you ever see that, it's basically telling you you're using a vector and you're trying to treat it like a list or a data frame, and you either need to convert it or get your crap together and figure out what you're doing. Easiest way to fix that is you can just say f equals as data.frame f, and that actually converts it to a data frame, which looks identical to the vector, but now you can say f $y, and there you go. So, but we'll get to data frames later. In fact, we're going to remove this abomination now. Okay, so we went through that. I give different examples in my R Markdown, but they essentially do the same thing. So let's see here. So we talked about all that. It says now you can get the row names and the column names using row name and col names, which I showed you already. So let's try this. Let's see here. Notes. Note that these are given as vectors and can be assigned Oh, so the row names and the column names can be assigned with vectors, which I kind of already showed you. So you can do statistics on your vector. So I'm gonna create a really large data set here with just a bunch of random numbers in it. If you want to ever make something with data random numbers, you can use the run if function. It's actually our uniform function, but it's spelled run if, and easier to remember that way. So we're going to create a vector called z that's got 100 numbers in it between 0 and 100. That's what that means. So we're just going to run that line there. Now if we look at z, we can see, okay, there's a single line vector with 100 numbers in it. Now we're going to make it a multiple line vector with just this little for loop here. So it's saying for a vector with the numbers 2 to 100, z equals r bind z and another set of 100 random numbers. So now if we look at z, now it's a multi-dimensional vector with 100 by 100 numbers. So you can see the size of your vector or your data structure by using dim. So it's 100 by 100 there. All right. So we can say, okay, so what's the average of all these numbers? Because there's 1,000 numbers here. Very quickly, you can get the average by typing mean z. So it's slightly higher than 1, or than 50. We could look at the standard deviation using SD. We could look at the maximum number that we get. We can look at the minimum number that we get. Basically, any function, you can run it on an entire data set. And some functions will give you the output of the combined. So obviously, if we do +1, so if we do z +1, it'll give us a whole data set with one added to each number in it. But for things like average of each individual number would be itself, so that wouldn't make any sense. So you can use statistical functions on the whole data set. So we can also do things where we get Boolean responses by doing comparisons. So if we say, okay, what is z less than 50 or z greater than 50? What it'll do is it'll return the entire table, but instead of returning the numbers, it'll return either true or false for each position, which is only useful if you have like a perfect photographic memory to tell you what is in each one of those positions. You can do multiple, multiple comparisons together. So you can say, what if there's a z over 50 or a z, show me numbers over 50 or numbers under 20. Show me true for those. Oh, if they're over 50 and under 20, which doesn't make any sense, right? But we could say under 70. So now this is just going to say true for numbers between 50 and 70. So 50, 60 together. And so here you can see more of them are false. You can also use or. So another caveat in other languages, and is a double ampersand. And or is usually a double pipe symbol, but for this it's just single ampersand or single pipe. So this is saying show me what ones are greater than 50 or what ones are less than, we'll say 30. And here we have it showing us this. So this is pretty much worthless, but now we can apply it to our data structure to actually change those things that come back as true inside the data set. So let's say, okay, I want z, and now if we put inside the square brackets our comparison, z less than 2, now it returns a vector in which every single item in that whole data set that was less than 2 comes back as a one-dimensional vector. So that's pretty useful. And if you want to know how many in that set were less than 2, you can use the length function. And now we can see 173 items in that data set of 1,000 were less than the number 2. Let's see here. So let's see here. So essentially, it may be a little confusing. So what this is essentially doing is say we made a data set called smalls equals z. So this is an empty vector. And if I were to say for x in z, and then what this is just going to do is it's going to go through every single item in the vector z, and we can do something to it. We can say if that item in vector z is less than 2, then we want to make our small set equal to itself combined with this new value. Oops. It helps to be consistent in your writing. Okay, so now if we look at this, now we've got this new set smalls, and if we look at its length, it's the exact same thing. It's 173. So instead of typing out that whole big for and if statement, we can just do all of that with the single line, which is z square bracket z less than 2. Boom, same thing. All right, so what we can do is you can actually alter the members of that set. So we can say z square bracket z less than 2 equals 100. And so what that did, we didn't return anything, but what that did is that went through the whole set, and it found anywhere that there was a number less than 2, and it should have changed it to a 100. So it might not have done it because I might not have assigned it. Let's check it out. All right, so here's our z. We just ran this function. So let's say z, and we'll say z greater than 99. Now you'll notice we got a whole, let's just say z double equals 100. So now we can see that we've got a bunch of these that are 100. And if we look at how many of them, oh my goodness, it's the exact same amount as we had before, which was 173. So we've changed all the numbers that were less than 2 to a 100. So what I hope you're getting from this is that you can use these kind of conditional operators and assignment operators to grab and modify data sets pretty quickly. So let's see here. So like say you've got some NAs in here. So let's see here. Let's see. So we'll say z 1 comma 1 is equal to dot is equal to NA. Okay, there we go. So NA is basically I don't know what the frick this is what it does. So if we do z, now we can go up and see the first item is an NA. So this is what happens when you say try converting letters to a number or something like that. Or when you combine two sets that are different lengths and it doesn't want to just try and fill in the extra space, you'll get NAs. So you can do something like z is dot NA. So is.na is a function that just basically tests if it's an NA, and then you can set that to 1, 2, 3. And now if we look at our z, now position 1 is 1, 2, 3. So this is a way to drop out. You could change NAs to 0. It's typically how most people do it. So there you go. Okay, so that's just some of the stuff you can do with vectors. And like I showed you, so you can say we've got a vector that, let's see here, so we've got vector 1, 2, 3, 4, and then we try combining it with C. Do that. Okay, so now, oh no, we've got numbers, but if we look at what they are using the mode function, mode will tell us this is a character set. So you can force sets to change what kind of data format they are with the as dot functions. So we can say z equals as dot double z. And now if we look at z, it's converted. It's gone through and said, okay, these all are numbers, even though they're characters of numbers. So we can convert these characters to numbers. So it's a way to take something, say you got confused when you were loading a table and somehow it loaded them as characters. That's a way to force them to numbers. I'm not actually sure what would happen if we did this with an actual letter in there. So let's just try this. Yeah, so if we had a letter in there, it's like, I don't know how to convert an F to a number, so it replaces it with an NA. And so then we can use our little thing as to is NAZ. So we can convert all our NAs to zeros, and now there we go. We've got a 0. So hopefully this has made a little bit of sense and not been too excruciatingly painful. But that's vectors. Pretty much most of the stuff you'll work with will actually be vectors or data frames. Every now and then you run into these things called factors. So factors are like these weird ordered vectors. And so factors are actually something you'll run into a decent amount. So like, let's say we've got this list here that's just a combinations of the word boys and girls here. Boom. Let's make it a factored list called gender. So what you'll see is if you look at it, you'll see boy, girl, girl, boy. So here's your list, your vector list, but then it has an extra thing called levels. And so what levels is is just all of the unique members of the set sorted either alphabetically or numerically. So it's essentially sort uniquing your set. And so what's really nice about this is it lets you use these kind of as labels with a table. So let's try this. We're going to skip this part of using numbers because it does, would show you that it does set unique. Well, let's do it. So we can do this with numbers. So if we take a bunch of random integers between 0 and 20, there you can see we got a bunch of random ones. If we look at the levels, there you go. There's our levels. So you can see it's only the unique ones. There's no repeating members of the set. As I say here, let's pretend it's Cinco de Mayo and tacos suddenly rain down from the sky on this set of gendered people. So we'll create a list called tacos. That's just a random 10 between 0 and 10. So now we've got these two sets here, gender and tacos. And so they're the same length. So you can see boy number 1 got 4 tacos, girl number 2 got 5 tacos, girl number 3 in position 3 got 2 tacos, etc., etc. We can use a function called tapply now to apply a function to these two lists. So what we're going to do is we're going to use tapply, and we're going to say, okay, look at the list tacos and the list genders. I want you to put them together, and I want you to tell me the average. And you're saying the average of what? So let's look at this. So it takes the factor, genders, and it gives us the average number of tacos applied to each member of those sets. So in this case, we've got a bit of gender inequality here with taco distribution on Cinco de Mayo. But so as long as you've got a list with that's a factored list, you can use this tapply with it. So we could also say, okay, who got the biggest amount? And you see the maximum amount distributed was the same. So this comes up in other places, but essentially just know that factors are like unique, a way of taking a large set that may have repeating members and making you getting the unique members out of it, and then doing math on those unique members. Yeah, that was a terrible explanation, but that's what you're going to get. So if you're confused, go back, read this, then ask me questions. But an example of where factors is used that you don't see it is with the table function. So if we just do table taco gender here, what you can see is we've got the number of tacos. So who received zero boys received 0 tacos, while 2 girls received 0 tacos, boys 1, blah, blah, blah. So essentially it gets the unique members of the gender set and then sees how many tacos each one got. So, okay, that's factors. So if you ever see something complaining about factors or you don't want it to be a factor, you can say as dots a data frame and get it out of factor form, because sometimes factors behave oddly when you are trying to work with them. But most of the time they're actually what you want. You know, this whole section here on arrays, I'm actually going to skip this because essentially you're never going to, well, arrays and matrices are the same things. They're just vectors that have more than 2 dimensions to them. So you can give them, you imagine a square, and then a cube is 3 dimensions, and then you can give it as many dimensions as you want. So this is useful if you're making like a directory structure, but for most of us, the data we work with isn't going to have more than 2 or 3 dimensions to it. And the math with these gets pretty complicated. So if you want more on matrices, we can maybe talk about that later, but we're not going to mess with that right now. So lists, I can't spell. Lists are actually something you will probably encounter a lot. Lists are essentially ours way of dealing with mixed data types being stored in the same object. So here's an example of, let's make this extra crazy. As dot integer 1. And let's not do cat, let's do 1.3. All right, so let's make a list object called A that has dog, integer 1, and the double 1.3 in it. So if we try doing this, so before we get too crazy, let's just try doing this with the concatenate function. What we do is we end up just with a list of character objects. But if we do it with list, what we're going to actually get is a list. And each member of the list, if it will be its own kind of set of things. So like, let's just try this. See, 1, 2, 3. All right. So look at this. So we can now have a character, a set of integers, and a set of doubles, vector doubles, all existing by themselves in a single storage object. So that's what lists are. And lists they can be a little bit confusing. So you'll see this double bracketed structure here. So this is the naming structure, and it is terrible because most people will try and treat it like a vector, and they'll say, okay, A1, what is A1? And they'll see, oh, there's dog. So let's say, let's try and change A1 to fish. And we look, and what the crap, it actually worked. Sometimes it does work, sometimes it doesn't work, and it's very inconsistent, and it leads to confusion. So let me try this. We'll say A1 is equal to C123. And we'll run it. Now let's look at A, and it goes, well, there is only one item, so it grabbed the first item from that list. So it didn't like that. You get confusing mixed results. And the reason is you can only replace a list item with something of the same length if you use the single square bracket notation. So that works, but the other one didn't. So say we actually wanted to do this, replace it with a vector. If you do the square brackets, that works. So there we go. So just remember, if you're working with this, the double square brackets work. Now, if you want to just convert individual members to a vector, you can either just call them by their double square bracket name. So if we call it by the single square bracket name, it gives us a list back. If we give it the double square brackets, it gives us a vector back, because there's a vector in that list position. The other thing you can do is use the unlist function, like that. What happens if we unlist the entire thing? Nothing good. It basically creates a vector of all the types that match. So if we had had a character in there, we would have gotten a vector back with every member of that list, but as characters, since it was a combination of integers and doubles, it just converted all the integers to doubles. So if you've got a list, don't use unlist unless you have to. Just call the individual members. One nice thing about lists is you can use the $ operator, so you can give the list members names instead of this double bracketed number thing. So let's say, okay, we've got A here, and then we'll do A square bracket 1. We'll do this again, C, cat, dog, fish. All right, so here's our A. So we can assign each member name. So just like we assign column names to our vector, we can assign member names to our list. So we can say names of A, and we'll give it a vector. Now that'll be animals, integer, and then double. And now if we go back and look at this, now we've got names associated with these, and it's easier to remember. So we can say A $ animals, and it gives us the vector of animals. Or we can say A $ integers, and it'll give us the list of integers. So in that respect, lists are pretty nice to work with. You just got to remember what you're working with is all. All right. If you want to just like save yourself time and you are creating a list on purpose, you can say A equals list, and you can assign those names while you're creating the list. So it's going to say animals equals C, cat, fish, dog, and then numbers equals 1, 2, 3, 4. And now if you look at the list, now those are have been assigned. They already have their labels. Okay, so So lists are actually really nice, but they're a little confusing. I know I've had some issues with them in the past, but hopefully this clarifies it. Hopefully the examples make sense to you. And if not, again, let me know if you want me to go further in depth on this. Now this brings us to data frames. Data frames are probably 90% of what you're going to run into when you're working with data. If you load in an Excel file with a read.table, you're creating a data frame. Essentially, everything we're working with is either going to be a vector or a data frame with an occasional list thrown in. So let's hop right into this. So let's create a data frame. So data frames and multidimensional vectors are pretty much the same thing, but data frames give you a little more flexibility on what you can do with it. So for example, let's say we've got a vector called buyer's names. And look, those names look familiar. And let's say we're just going to create a random list with those people in it. So we've got our buyer. So that's just random numbers. And if we say buyer, hopefully you were paying attention earlier and can kind of follow what I'm doing here. I'm assigning buyer equals buyer names with the buyer vector. And what this does is it gives us a randomized list of the Gertz lab members' names. Hopefully I didn't forget anybody. Sorry if I did. Okay, so now we've got a list of these, and hopefully you can recognize that factors will be useful for this. And now we'll just say we've got a list of things called payments. There are 100 of them between 1 and 100. Okay, so here's our payments. There's 100 of those and 100 of our names. And now let's say, okay, let's create a data frame. So the way you make a data frame is with the data.frame function, and we're assigning it to df, and we've got buyers and payments that we're gluing together into this data frame. So if we look at this, this is going to look a lot like that multidimensional vector. Surprising, huh? So if we want, so we can say df.buyer. Oh, look, and you can see it's already converted this into a factor. So the data frames can contain lots of different types of data, kind of like the lists, but it's got them, it's a weird combination of lists and vectors and factors, I guess. And then we can do the same thing with payments. See, it's a vector of doubles. And now let's say we wanted to give them give row names to this. So we can make this RN thing, which is a vector of the numbers 1 through 100 with transaction just stuck on the front, just because, why not? And so now the way we assign row names is we say row names of our data frame equals row names. And now if we could do head df, we can see we've got, instead of just random, or instead of just numbers, we've got transactions followed by numbers as our row name. So we can say df, this won't work. No. Df square bracket comma transaction 1. Yeah, I can't spell apparently. Oh, it's because I got it in the wrong spot. Transaction 1. This is painful. Okay, and then you can, grab whichever row you wanted. Okay, so that's cool. Now we've got a data frame. Now what are we going to do with it? So say we create a second data frame, which I'm going to do that with a lot less steps by just combining a whole bunch of steps into one. So I'm creating a new kind of the exact same thing I did with the buyer names, creating a list, but we're going to call this one consumers here. And I'm going to make a second data frame called df2. And what we're doing is we're combining this consumers list. So everything after this equal sign, I could have just stuck in here and this would work. I'm assigning the row names inside the function. So row.names is just inside the function. And we're creating 105 transactions this time. So I'll show you what happens when you combine a smaller set with a bigger set. And then we're adding another column called tacos purchased, because Cinco de Mayo is somewhere in the next year or so. Never remember the date. So now we've got data frame 2 here. Let's do this. Head data frame 2, head data frame. And you can see, okay, these have similar row names, and then they've got each have 2 different columns. So there's a couple different ways you can combine data frames. This is the way I tried the merge function. The merge function is annoying because you have to reassign the row names. So this is the way we're going to do it, is we're going to create data frame 3, and then we're going to use the data frame constructor. And what we'll be doing is we'll make it by combining data frame 1. And this square bracket step here is to force it to be in the same order as data frame 2. So it's saying the rows of data frame 1, I only want the rows that have the same row names as data frame 2, and then also data frame 2. What happens is if your rows have the same names but aren't ordered the same, and you don't put that in there, you will get you'll get a data frame with 2 lines that are the same length but not in the same order, which caused me some major confusion earlier this month. So just pay attention. That's how you do this. So that's how you combine data frames. So now if we do head data frame 3, you can see we've got transactions 1, 2, 3, 4, 5, 6 on the left, and now we've got buyers, payments, consumers, and tacos purchased all on the same row. But if we go down to the bottom and we tail data frame 3, the last 5, which is everything after transaction 100, weren't in data frame 1. So it gives us a bunch of NAs for anything that was in data frame 1, including the row names, which is weird. But I understand why it's doing that, and you guys probably don't care. But if you do care, you can ask me later. So to fix that, we just do row names of data frame 3 equals the row names of data frame 2. This data frame 2 had all the same row names. So there you go. We've patched that up. Actually, we could have just fixed that by building data frame 3 like this. Names equals row names df2. Helps to spell things correctly. Now let's see here, tail. Yeah, there we go. So save yourself a step and just define the row names in the data frame constructor or function. All right, anyways, so okay, now let's do some interesting, it's going to be super interesting math with this. So we've got data frame 3 here, and let's say we want to create a third column based on other data here. So we're going to create a column called PPT, or price per taco, and we're going to fill that column with data frame 3 payments divided by data frame 3 tacos purchased. So if we hit enter and we do head df3, you can see now we've got another column that now has the price per taco. So for example, in transaction 1, Jay bought 63 tacos, or bought 6 tacos for $63, so he paid $10.50 a taco or thereabouts. So now we can say, we can do some math, and we can use the tapply function here to say what was the average price that the average price per taco paid down here per buyer. So remember, the buyers is a factor, so it's going to break those down into the unique members of the list, and we're just going to apply the function here. And voila, here we go. Looks like Miss Adriana here got, oh no, Crystal got hosed the most on the price per taco. So we can actually plot these using bar plot. So here on the right side, you can see who got ripped off. Look at that. I'm so thrifty. Yeah, so if you want cheap tacos, I guess come talk to me. We can do the same thing with the minimum. Let's say who got the cheapest taco. Again, look at me being thrifty, and Matt got ripped off for a taco at some point. We can also, oh wait, that was the most expensive one. So here we go. This is the least expensive one. Looks like Christina actually got the cheapest taco too. So that's cool. You can do things like histograms. So this is looking at the number of tacos purchased per buyer, and this is the total number of tacos bought. Let's see, Matt bought the most tacos. Again, just go back, play this video back slow, take your time watching it, and it might make more sense. Here you can see this is the tacos purchased per consumer. I just have this random column like somebody else is eating the tacos that the other person is buying. So we can say who ate the most tacos. Looks like Hosey loves tacos. So there you go. You can, once you have data frames, you can do all kinds of stuff with it. I'll talk about more graphing stuff like heat maps in a later episode of this. So we'll see. The last thing I wanted to point out is the transform function. So if you have stuff in columns that you want as rows, or rows that you want as columns, so we've got our data frame 3 here. You can see the transactions are the rows, and all these different categories are columns. This is how we want it, but say we wanted it a different way, we could say use the T function on it. And now you can see the columns have become the rows, and the rows have become the columns. So one last thing, so I just found this out today after reading the manual. So say you get a list, so probably not many people are working with this, but if you get a list back, so let's create a list object, and we're gonna make this like a JSON object here. So, if you want to completely clear your environment, you can use this remove list equals ls. And this basically gets rid of all your function or all your variables. So, yes, your df3. df3 is not there. So that just unset all my variables. Okay, so let's make a list called dog. And you can see this list I'm creating. Name is Rufus, age is 1, weight is 2, NT2, color is yellow. So now if I look at this, there's all those things. So I can call it using dog $name, and it'll be, there's Rufus, or dog $weight. There's that. So say you've got something like this, and it's got some long, horrendous name that's way bigger than dog, like dataset 12796423, and you don't want to type that out every time, and it's the only dataset you're working with at the moment. You can use this function called attach, and then you put in your dataset, and now I can just type name, and it brings up Rufus, and I can type weight, and it brings up his weight, and I can type color, and brings up his color. So it essentially takes all of the names from the list or the data frame you're working with, and sets those as their own variable in the in your environment. And then you can get rid of that by using the detach function, not deteach. Detach. And now we do name, Rufus is no longer defined. All right, I hope that was less confusing and more helpful than I'm afraid it was. Again, I would suggest just walking your way through this, and then once you've slowly watched the video, walked through this a little bit, anything that's not clear, go ahead, write me questions in coding hell, and let me know what you think I need to clarify. Again, this is just a start. I'm going to move on to some functions, kind of work with a functional data set, maybe like an RNA-seq or an ATAC-seq data set, just to give you guys an idea of different things you're going to work with in R, like how to make PCA plots and stuff like that. All right, bye.